Hello, my students. Hello, everyone. Hoping you are doing well and staying safe at home. Today, we're gonna revise the reaction stoichiometry problems, the mole ratio, and the stoichiometric calculations. The reaction stoichiometry problems have four types. The first one is the given and unknown quantities are amounts in moles. The amount of given in moles and the amount of the unknown in moles. The second type, the given in moles and the unknown is mass. The amount of given substance in moles. So we need to have the amount of unknown substance in moles using the mass of the unknown substance. Problem 3. The given is mass and the unknown is moles. The mass in grams can be easily converted to moles and mole conversions. The fourth type, mass against mass. Each mass can be converted into moles, the mass of the given, and then calculating the moles, then converting it into mass. First of all, I'd like to define the mole ratio, which is the conversion factor that relates the amount in moles of any two substances involved in a chemical reaction. Example, 2Al2O3 in the liquid state, resulting 4Al in the solid state and 3 oxygen in the gaseous state. The mole ratios between the aluminium oxide and the aluminium solid is 4/2. And aluminium oxide with that of oxygen is 2/3. The last one, the aluminium and the oxygen is 4/3. The conversion can be held as the follows. First one is to identify the amount in moles using the coefficients from the balanced chemical equation, multiplying the original amount by the mole ratio as it will be shown in the next slides. The calculations, just to have a quick look, the volume of substance in milliliters times density resulting the mass times ratio of mole over molar mass giving the amount of substance times 1 over Avogadro's number giving also the amount of mass times the mole ratio giving the amount of the another substance, and so on as shown in the diagram. The conversion in moles, the amount in moles times the mole ratio resulting the unknown substance in moles. Again, the amount in moles times the mole ratio resulting the amount of unknown. Using the given figure, the mass times 1 over molar mass giving the moles times the mole ratio giving the moles times molar mass over 1, the inverse of this, giving the mass. To be more practical, in sample problem A, in a spacecraft, the carbon dioxide exhaled by astronauts can be removed by its reaction with lithium hydroxide, according to the following chemical equation: CO2 plus 2LiOH, resulting lithium carbonate and water. The question is, how many moles of lithium hydroxide required to react with 20 moles, which is the average amount exhaled by a person each day? Here I have got two criteria of method. The first one is using the mathematical proportion for each 1 mole of carbon dioxide reacting with 2 moles, then X moles reacts with 20 moles, like that. 1 mole reacts with 2 mole. Then the 20 mole reacts with how many moles using the cross multiplication. Or using the given equation, the amount of CO2 is 20 moles, which is the given, the unknown LiOH, the solution using the mole ratio, moles of known times the mole ratio unknown over known, giving the number of moles, 20 times 2 over 1, resulting 40 moles of lithium hydroxide. Moles to mass conversion, the amount in moles times mole of the unknown over mole given times molar mass over mole unknown, resulting the mass as the following. In the photosynthesis process, plants use energy from the sun to produce glucose, C6H12O6, and oxygen from the reaction of carbon dioxide and water. What mass in grams of glucose is produced when 3 moles of water react with carbon dioxide? The givens: through the balanced reaction, 6CO2 plus 6H2O, resulting C6H12O6 plus 6O2. The given is the amount 3 moles of hydrogen, the unknown mass of C6H12O6. I have here also two types of method. To use the proportion like this, H2O and C6, every 6 moles resulting 1 mole, 3 moles resulting X moles, cross multiplication. Or using the mole factor, the molar mass conversion factor, the moles of H2O times C6H12O6 over H2O, 1 over 6 times the molar mass of the glucose, which is 180, it would be given of course, over 1, resulting 90 gram C6H12O6. That was all for today. Study hard and try to resolve these examples using written steps and written calculations. And if you like to express something or ask about something, you can email me or check whatever the contact method is.